It's 9:10. It's 9:10.
Hello? That was Minnie Mouse, but this is Mrs. Lehman from Math with Mrs. Lehman, and I'm here with my third period class.
Hi.
Who's a little extra giggly today.
Yeah.
Anyway, we have a bell ringer. It says write the absolute value of -9, 34, -67. So who can tell me what the absolute value of -9 is? What is the absolute value of -9? Jaden, nice and loud.
9.
Very good, 9. All right, absolute value of 34. Willow.
34.
Very good. And the absolute value of -67. Justin.
67.
Very nice. All right, what do we notice? All of these ended up being what type of number? William. Oh, you just stole William's thunder there. They all are positive, right? Because when you have an absolute value, it will always end up as a positive. So it says convert 4/5 to a decimal and a percent. So 4/5, we would write this like that. How would I turn any fraction into a decimal? What would I do? Thank you for raising your hand, Elijah.
You put equals 100 blank over 100.
Very good. That's one method. Okay, so you want to set up a, what do we call that when we have two equal ratios or equal fractions? Tim, shout it out. Louder, Tim.
Proportion.
Very good. Proportion. So we're going to scale up 4/5 until we get it out of 100. This works with certain denominators, so take advantage of it if you can. How many times do I have to multiply 5 to get up to 100? William?
20.
20, thanks. They let you answer. All right, so do the same thing to the top to keep it proportionate. 4 times 20 is 80. So we still haven't turned that into a decimal or a percent, so what do we need to do now? As I wander the room looking for the person who will save us.
You need to go and you need to put 0.80.
And how would you read that decimal? 0.80.
0 and 18.
0 and 8/10 or 0 and 80 100. Yeah, same thing. Right? We don't need that 0 at the end at that point. Just like this could be simplified down to 8/10, right? We could write it 0.8 or 0.80. So that's a decimal. How would I change this? We're looking at this fraction again, 80 over 100. How do I turn that into a percent? It's pretty easy, right? Percents are out of 100. So if you have a fraction where it's out of 100, then your day is made in the shade, kids, because you just take that top number. So that would be 80%. Now, you also notice a decimal point here, right? So when it's a decimal and you want to change it to a percent, we move that decimal place. How many spots, Julius?
2 to the right.
You got it, kid. 2 to the right. Right? If we have a percent, like we do right here, and we want to make it a decimal, we would take this decimal and move it 2 to the
Left.
left. Very good. All right. Now, when you entered 6th grade, I think most of your minds were blown because that fraction bar, I told you, could also represent what?
Division.
Very good, division. So you could take 4 divided by 5. You do top divided by bottom. So 4 is being divided by 5. 5 gets to play the role of divisor. So 5 goes into 4 0 times. So when you were in elementary school, you would have said 0 remainder 5. Yeah. All right, but you're in 6th grade, so we have to add decimal points and zeros and all that good stuff. So a decimal point and a 0. 5 goes into 40 how many times?
8 times.
8 times. So that's another way of getting to that. So if you have a fraction that doesn't have a nice denominator that will scale up easily to 100, you always have the option of taking your numerator and dividing it by your denominator to turn any fraction into a decimal, and then it's really easy to turn that decimal into a percent by just switching or sliding the decimal over 2 spots. All right, any questions on that? Right, today we are going to maybe move forward if this smartboard wants to work. We're going to go over your homework very quickly. well, I say very quickly. I'm in slow motion today. So, we are comparing the absolute values actually they use the word magnitude, which means the same thing. What do absolute value and magnitude mean? What's the definition of that? People are frantically looking at yesterday's stuff. Some people are sitting there waiting for their neighbor to do it for them. You know? No? All right, Elijah.
Absolute value and magnitude is distance from 0.
Very good. So you look at a number line, it's how far from 0 it is. And it doesn't matter whether it's positive or negative, you're just saying how far away it is. Nice job. So we are comparing these two quantities' absolute values. I'm not sure if I said that correctly, but all right. So pretty much we are going to strip away that negative sign in front and just compare the magnitude of each. All right, so 33 compared to 52 is, 33 is what to 52? Mackenzie?
Less than.
Very good. So we know the bigger one is 52. This one we have negative 14 compared to 23. All right, so again, just take that negative sign off of there. We're talking about 14 and 23. Which one has a bigger magnitude? Everybody?
23.
23. So who can read that left to right for me? Timothy?
14 is less than 23.
Beautiful. All right, so that was pretty much the gist of that. So we're comparing 24 and 6/10 compared to, well, negative 24 and 58 hundredths pounds. So again, absolute value of this compared to the absolute value of this. We're going to just take away the negative signs. So 24.6, 24.58. Now, a lot of kids coming into 6th grade, because up until this point they've only dealt with really, a handful of fractions and stuff, but mostly they've dealt with whole numbers. So they think the more digits there are in a number, that always means that it's a bigger number, right? Not all of you guys thought that, but there are some people. When it's a decimal, that changes, right? Because we could throw zeros on the end here. We could do a lot of different things, and more digits does not mean a bigger number. So we're comparing 24 and 60 hundredths to 24 and 58 hundredths, essentially, which is the little guy in this case. Ethan, which one is smaller?
Which one is smaller would be the 24 and 5800.
Very good. Yep, so we're going to point at the little guy, alligator mouse going towards the big guy. All right? Then we have negative 11 and 1/4, which, if we're just comparing these two numbers, that's definitely smaller than a positive number, right? But we're comparing their magnitude, so again, we're just looking at them as if they were positive. So 11 and 1/4, that is not supposed to be there. All right, 11 and 1/4 compared to 11. Which one is further from 0? Which one has a greater magnitude? Everybody?
11 and 1/4.
Oh, good. I thought they were asleep for a second. It's nap time in Mrs. Lehman's class. This is so easy, it's almost boring. All right. So the absolute value of a negative number will always be a positive number. Is that true or false? True. Very good. It's always going to be true. The absolute value of any number will always be a positive number. Also true. Very good. The next one, positive numbers will always have a higher absolute value than negative numbers, or a negative number. Everyone?
False.
False. There's no trick in you kids. Can someone give me an example that proves this? That we could have a positive number that actually has a lower absolute value than a negative number. Do you have an example to give? Can you come up with an example? We want to prove that this is a false statement. It's saying that positive numbers are always going to end up with a higher absolute value or always have a bigger magnitude. And we want to prove that that is not true. Jaden?
So
I'd put -7 absolute value and a +6 absolute value and compare them.
Very good. So I'm going to write down what Jaden just said. So if we have the absolute value of -7, right, that has an absolute value of 7. And if that's a negative number, -7 compared to 6 is definitely less. But because we're looking at their absolute value, this is a positive number with an absolute value of 6, right, which is definitely smaller than this negative number's absolute value. Because again, we don't care if it's negative or positive, we're just looking at how far away it is from 0. Nice example. All right, we're going to skip 8 and 9 because everyone's problem is going to be different. I'll pause it and go over that with the kids. 10, look at the bank account transactions listed below and determine which has the greatest impact on the account balance. Explain. So when you see the word withdrawal in a bank account, what does that mean? Money's going in or out?
Out.
Out. So that's going to be what type of number?
Negative.
Very good. So -60. If we're looking at the impact of that on the account, it's going to affect the account by how much money? Everybody?
60.
60, yep. A deposit, and remember you can think depositive. Absolute value of 55 is?
55.
55. See, this, I don't know, this is not challenging. All right, the absolute value of a withdrawal of $58.50. Well, a withdrawal means it's what type of number?
Negative.
Negative, so 58.50. Oops, that 5 got a little wonky there. Again, let me fix that. There we go. All right, that's going to be $58.50. So which has the greatest impact? Which one is going to change the account for the better or the worse the most? Yes, Liz.
A withdrawal of 60.
Very good. So this one would be the greatest impact on the account because it has the greatest absolute value. Very good. Greatest magnitude. All right, any questions on that? All right, I'm going to pause this for a second while we talk about 8 and 9. All right, good examples for 8 and 9. We are going to move on to today's lesson on, I'm not sure which page in your module, but it's lesson 13, statements of order in the real world. 48. I'm skipping a bunch of stuff on this today. I'm sure it's going to break a few hearts, but
I don't think so.
pretty much all we're looking at is, do you know the wording that would indicate a positive or a negative number? Okay, so we've talked about temperatures before. In question 2, it's talking about a bank account and whether money's going into the account or leaving the account. And later on, there are some other examples. But we're going to look at number 1 together. So it says, scientists are studying temperatures and weather patterns in the northern hemisphere. They recorded temperatures in degrees Celsius in the table below, as reported in emails from various participants. Represent each reported temperature using a rational number. Order the rational numbers from least to greatest. Let's underline that. So they're looking for the smallest number first. And we need to explain why the rational numbers that you chose appropriately represent the given temperatures. We're going to kind of skip that because we're going to talk about it together. All right, so they say 8 below 0, so the temperature there would be what? 8 below 0, everybody, would be?
-8.
Yeah, this isn't even that complicated. So -8, they gave you, this next one is just 12. Right, 13 below 0 would be?
-13.
-13, we've got 0. 2 above 0 would be?
2.
2. 6 below 0 would be?
-6.
And -5 they gave to you. Tough job here. Okay, so what we're going to do now is put them in order from least to greatest. So remember, we're looking for the numbers furthest left on the number line first if we're going least to greatest, right? So the biggest negative number, if that makes sense. So what is our smallest valued number here?
-13.
-13, everyone agrees with him, Elijah? Yep, all right, so -13, let's put a check mark, we did that one. All right, what would be next? Julius?
-8.
-8, good. And Deja, what would be next?
-6.
-6, very good. I should start wearing tap shoes, because then you guys would know I'm walking around to kids, and it would be much more fancy. All right, so I'd probably get annoying in about 3 seconds, because I wouldn't have any cool rhythm that makes tap dancing cool. I would just be walking. Negative, what would be next? Everybody? -5. What? Ooh, delayed response on smartboard. All right. And then what is next? 4. Yawn. All right. Well, we finished all the stops on the negative side of the number line. Now we're where? How many times Jasmine said it? 0. 0. You are my hero. Okay. And then what's next after that? 2 and way in the back. 2. All right, very good. And the biggest of all of these temperatures, which is really sad. Oh, those degrees Celsius, so it's not that bad. Justin? 12, you got it. Okay. The next question, I'm going to have you work with a partner on. So your job is to think about whether or not debit or credit are positives or negatives, and then order these from, if you read up here, greatest to least. You're looking for the biggest to the smallest. Any questions on what you're doing? I'm going to have people work with their table mates, so why don't you guys get started and I'll pause the video. Okay, so this is the answer. You're welcome, YouTube. Okay, we're going to move on to the next question. So we have question 3, and it's talking about a swimming pool and how it fluctuates in its depth. So Madison's got all these readings here. You'll notice those are all written as fractions, right? To compare fractions, before we can even consider putting them in order from least to greatest, in this case, least to greatest, what do we need to do with those fractions? We want to compare them. They should all have.
Convert them into.
You could convert them to. Were you gonna say decimals? You could, and then they'd be really easy to compare. But these are pretty simple fractions, so we need to make sure they all have
The same denominator?
Yep, a common denominator. Then it's super easy. So we have 1/2, 1/4, 1/8. What can we use as a common denominator there? Common denominator. What can we use, Jaden? 1/8. Well, we could use 8s, right? So let's use 8s. Oh, that one's 1 and so many 8s. Now we have to still decide whether or not these are positive or negative changes to this pool. So if it's above normal, we're going to put a positive. If it's below normal, we're going to put a negative. All right, so we have 1/2. Let's turn that into 8s. Convert it to 8s. What would 1/2 as an 8? As 8s. How many would that be, Deja? 4 8s. Nice. All right, so 4 8s. It says above normal, so that's going to be positive. Yep. Above normal for the next one, so this is also positive. 1/4. What would that be as far as 8s, Mackenzie?
2 8.
2 8s. Good. 1/2 would be how many 8s? Everyone? 4 8s. And it says below normal, so it would be
Negative.
negative. All right, you guys get the point here?
Yeah.
All right, so your job tonight is to finish this question and do the next question as well. All right? Again, don't get hung up on the wording and, oh, what is barometric pressure? You know, whatever. Rise would be positive or negative?
Positive.
Fall would be positive or negative?
Negative.
Negative. Yep. So you're putting these in order from least to greatest on this example, and least to greatest on 3 as well. So that's your homework for tonight. Thank you for tuning in to Math with Mrs. Lehman. Please don't forget to like and subscribe. And I hope everyone has a mathematical day. Math-magical day. And so does Minnie Mouse.
It's 9:37.
Goodbye.